Let's continue with the solution to the guide from the Division of Basic Sciences and Engineering at the Metropolitan Autonomous University. In the previous video, I solved exercises 13 to 22. If you haven't seen it yet, I recommend watching it first to follow along in order. In this video, I'm going to solve another 10 exercises. We'll start at number 23 and finish at number 32. So, let's get started right away with the exercises. Exercise number 23 says, Jose and Juan each received a monthly salary of $10,000. After some time, Juan got a better job with a monthly salary of $15,000. Together, they earned $530,000 over a period of 2 years. What is the equation that allows you to determine the number X of months that Juan was at his first job? The first thing I'm going to do is write what X will represent. Remember, it's the number of months that Juan was at his first job. Now, if they're telling us that it's a period of 2 years, then start thinking about how we would represent the number of months that Juan has been at his second job. Well, it's very simple. What we would have to do is use the 2 years, but convert it into months, which is 24 months. We're going to subtract the number of months he was at his first job, right? Which is X. This right here. I mean 24 minus X. That will give me the number of months that Juan has been at the second job, right? And now, we're ready to write our equation. I'll start with Jose. Let's see. We already know that Jose has always earned 10,000 pesos a month, right? Therefore, if I want to know the amount of money he contributed in these 2 years, I would simply have to multiply what he earns per month. Jose, that's 10,000 times the number of months in 2 years, right? Well, in 2 years, that's 24 months. So 10,000 times 24. Now that's going to give me what Jose contributed from these 530,000 pesos in those 2 years. That is, in 24 months. To this, we're going to add what Juan contributed from these 530,000. But when he had his first job, remember that when he had his first job, he earned 10,000 a month. Therefore, I'm going to multiply 10,000 by the number of months he worked at his first job. Remember we said it was X, so I have 10,000 times X, right? Okay? And to this, we're going to add what he's earning at his second job, multiplied by the number of months, that he's been at his second job, which in this case is 24 minus X. All right, now we have the sum. So what should this be equal to? Well, 530,000. There you go. Look, right now, just like that, we already have the equation. Obviously, we still need to work out a few things here and also simplify. Because look here at how we have the input numbers. I want you to notice that there's a 530 in all the answers. This means they divided by 1,000, so we're going to do that too right now. All right. Let's start then by multiplying 10,000 by 24. In this case, then I'll have 10,000 times 24. So I write 24 and add 4 zeros, right? Plus, here we have a 10,000x. I'm going to write 10,000x plus. Here we have 15,000 times 24. So we'll have to do the multiplication. I'll do it over here so it doesn't get in the way. I'm just going to multiply 15 by 24. Remember, we have to do everything manually. 5x4 is 20. 4x1 is 4 plus 2. Carried is 6. 2x5 is 10 carry 1. 2x1 is 2 plus 1 carried is 3. This gives me 0 here. 6, and here 3. So, 15 times 24 totals. 360. 360, so I just add 3 zeros. 1, 2, 3. Now we're going to multiply 15,000 by X, or, well, 15,000 by minus X, which gives me minus 15,000X. And on the right side, we still have 530,000. And now we're going to divide by 1,000 on both the left and right sides of the equation. So let's do it. If I divide by 1,000, well, let me do this. Here, I'm going to remove 3 zeros. Here, too, I'm going to remove 3 zeros. Here, too, and here, too. And so, I'm quickly going to write down what I have left. Remember that what I'm doing is simply dividing both sides by 1,000. And that's it. Well, I'm just writing down what I have left, and this is what I ended up with. I have 240 plus 10x plus 360 minus 15x equals 530. Let's find the correct answer. It seems like this one, but it has a negative here. We have 240 10x, 360 minus 15x, and 530, right? So the correct answer will be option E. Let's see. Here, I already have the answer key that comes in the guide, and it says that indeed the correct answer is option E. So we're going to check it off. That's done. Now let's move on to the next exercise, which is number 24, it says. When Sarah opened her piggy bank, she found 4,850, 100, and 200 bills. She also noticed that the number of 100 bills was 3 times the number of 200 bills, and that there were twice as many $50 bills as $100 bills. How many 100 bills were there in the cash register? Well, this is definitely a system of equations problem, right? So come on, let's set up our equations. I'm going to write the equations I find in blue, okay? So let's go. It says that he had 4,800 in bills of this denomination. So I'm going to call the number of 50 bills X. I'll call the number of 100 bills Y. And I'll say that Z represents the number of 200 bills. Okay, all right. So now we're ready to set up our system of equations, which, as you can see, should be 3 equations, right? So let's see where we can get them from. We can form an equation stating I had 4,800 pesos in 50, 100, and 200 bills. How should I write this? Well, let's write it down, right? 50 pesos times what? Times the number of 50 peso bills, right? All right, I'll just leave it as 50x. This plus what? 100 pesos times the number of 100 peso bills, and plus 200 pesos times what? Times the number of 200 peso bills has to give me the total that Sarah collected, which in this case is 4,800. This is an equation, right? Now let's look for the other one, it says. I also noticed that the number of 100 bills was 3 times the number of 200 bills. So the number of 100 bills, we were representing it with a Y, right? And Y is 3 times what? Of the 200 bills. And the number of 200 bills is represented with Z. So I have that Y equals 3Z. That's another equation, right? Let me move it here. E equals 3Z. And finally it says, and that the 50 bills, which are represented by the letter X, were double the 100 bills. Okay, so X, which are the 50 bills, well, the number of 50 bills was double the number of 100 bills. The letter represents the $100 bills, and so I'm going to set it equal to 2e, and that's it. Now we have our 3 equations, so all that's left is to solve them. Here, it's asking how many 100 bills were in the cash register. Let's check the number of 100 bills. It's represented by the letter Y. So what we have to do is write an equation, but everything in terms of Y, right? So that when I solve it, I can directly find A. So what am I going to do? Well, from here, I'll have to solve for Z. I insist because I want one equation with everything in terms of Y, since that's what I'm solving for. So, we can move this 3 down here, dividing, so that I get I over 3 is what Z equals. Notice X is already isolated in terms of Y, so we can substitute directly. Allow me to do it on this side then. So here I have 50x, so I'm going to write 50 times x. But who is x? It's 2e. So let's write it like that. Then it's plus 100e, so I write it just like that. 100e and plus 200z plus 200 times z. But we've already seen what z is and split into thirds. And this has to be equal to 4,800. All right, as you can see, now we have the equation and we only have one unknown, which is y, which is exactly what we're looking for, right? Let's solve this equation quickly. 50 times 2. Y gives me 100e plus. Over here, we have another 100 each. Here we have 200e over 3. And on the right side, we have 4,800. Well, 4,800 E's. Let's see. Here I'm going to do something very similar to what I did a little while ago. Notice that I can divide both sides of the equation by 100, right? So what I'm really going to do is just remove 2 zeros from this term, also 2 zeros from this term, 2 zeros from here, and 2 zeros from here as well. So I have just y left, plus another y here and another one there. I'm left with 2/3 of y. 2/3 of y. And on the right side, I'm only left with 48. Look, now we have a super simple equation, right? What I'm going to do next is multiply both sides of the equation. That is, both the left side and the right side, by 3. That is, by the denominator we have here. Let me put it like this, with an asterisk. Okay, there it is, 3. All right, so we multiply everything by 3. 3 times y is equal to 3y, plus 3 times y is also 3y, plus 3 times 2 is 6. Divided by 3, that gives me 2. What 2y? And on the right side, we have 3 times 48. Let's do it quickly. Here, 3 times 8 is 24. Carry the 2. 3 times 4 is 12. And the 2 I carried makes 14. Let's do this addition. 3y plus 3y is 6y, plus 2y makes 8y. This equals 144. Finally, we have that y equals 144/8, right? Since the 8 is in the denominator, we divide. I'll do it here. 144 divided by 8. Here, 1 fits. 1 times 8 is 8. 1 4 minus 8 is 6. Bring down the 4, 8 fits. 8 times 8 is 64. 64 minus 64 is 0. I'm left with 18. Therefore, y equals 18. But don't forget that y was the number of 100 bills. And this would be the answer, right? Because that's what it's asking, for the number of 100 bills that were in the piggy bank. So the answer is 18. Therefore, it's option B. Let's quickly check if number 24 has option B as the answer. Yes, so we got it right. Great. Let's continue with exercise number 25. On an avenue, there are 2 buildings facing each other, with their bases 40 meters apart. The height of one is 45 meters, and the other is 35 meters. If someone stands on the avenue between the 2 buildings, how far from the taller building should they stand? So that his distance to the rooftop of each building is the same? Okay, it's important that you read the exercise carefully, because many times we can't solve it because we didn't really understand what it was about. I'm going to use the little drawing, that I'm going to make. Next, I want you to really understand what the problem is about. Okay, so let me quickly draw the 2 buildings it's talking about. The problem in this case, let's think that it's referring to the distance from the ground. Okay, well, you'll see what I mean in a moment. Look, here's the taller building. I'm going to write the number here, which says it's meters tall. And over here, we have the smaller building, which says it's 35 meters tall. What it wants here is that if there's a person located somewhere, the distance from where this person is. Let's suppose that from their feet, okay, up to here, that is, to the top of this building, is the same as the distance from where the person is to the top of this other building. Let me draw straighter lines, because that looked kind of messy. Sorry. So this distance should be the same as this distance, okay? That's what we want. So, if I'm going to represent this, for example, with the letter D, let's write D. Then this distance from here to here should also be D. That's what we want, okay? And the information we're given is what you can see. But also, there's another piece of information that says the bases of the buildings are 40 meters apart. So from here to here, it's 40 meters. So also, 40. Let's write it down, because obviously this is a super important piece of information, right? All right, let's see. I think you'll agree with me that we definitely have to use the Pythagorean theorem here, right? It really fits perfectly, because as you can see, here we have one leg, here we have another leg, and over here we have the hypotenuse for this right triangle that's being formed here. And over here we also have a leg, and a hypotenuse. For which one? For this other right triangle being formed here. So let's set up our Pythagorean theorem for the 2 right triangles that were formed. But first, it's absolutely necessary that we know what we're going to put here. Because you see, this is exactly what we don't know, right? So I'm going to call this x, okay? That's what I'm looking for. I'm trying to find out how much x is, which is the distance, right? How far from the tallest building should you stand, so your distance to each rooftop is equal? So, we want to find the distance from here to here. Okay, where the person is going to be located. That's why I say we're going to put the variable x right here. Or, well, the unknown x. Because once we find it, that's going to be the solution, right? All right. So now, if this here is x, start thinking from here to here. I mean, how much does all of this measure? It's 40 minus x, so 40. X? Why is that? Well, because if all of this measures 40, and you already know that this little piece measures x, then this measures 40 minus that little piece x. Right, perfect. Once we have that, the next step is simply to set up the equation. Sorry, we just need to do the math. So let's set up our first equation. Here we have that x squared. I'll write it over here. X squared plus 45 squared, applying the Pythagorean theorem, is equal to what? Well, it's equal to the distance squared, that is, d squared, okay? We already have the first one, so let me box it, and let's set up the second one, which would be for this one. In this case, we have 40 minus x squared plus 35 squared. We already have both legs there, 35, squared. It has to be equal to the hypotenuse squared, which in this case, well, is also. So that's why we write d squared. Now I want you to notice something. Since d is equal, well, this d is the same as this d. So does that mean that d squared is also the same as this other d squared? Therefore, the value of this d squared, which is this over here, has to be the same as the value of this d squared, which is this over here. So, can I set these left sides of the equations equal to each other? Okay then, let me do that. So I would have, let me put this one here on the left side first. Okay, I'll put this one here first. Therefore, I would have 40 minus x squared plus 35 squared. That would have to be equal to what? Well, to this, right? Which is x squared plus 45, x squared plus 45 squared. There it is, right? All right. So from here we have to solve for x. It's not that hard anymore. Come on, let's do it here. First, I have to expand this binomial squared. So I get 40 squared. 40 squared minus twice the product of 40 times x. And plus x squared, right? Is this how it looks? It's a binomial squared. I'm squaring the first term, subtracting twice their product, then adding the square of the second term. I've already expanded my squared binomial. We continue here. We still have a 35 squared, and on the right side, we still have an x squared, plus 45 squared. Allow me, I'll scroll up a little to continue there. Let's go. All right, come on. In this case, how can you tell? I can cancel out the x squared terms. Why is that? I could subtract x squared from both sides, making x squared minus x squared, which is 0. But to avoid having to move it over, I already know that since this one is positive and this one is also positive, they're going to cancel each other out in the end, right? Well, here I have to do some operations that take a little bit of time, so let's go. I'll do them quickly. 4 squared is 16, and then I just add 2 zeros, right? So, 40 squared is 1,600 minus 2 times 40. That's 80. What x, Also, 35 squared. I'll calculate that here. Remember, you need to do it manually. 5x5 equals 25, carry 2. 5x3 equals 15 mas, plus 2 equals 17. 3x5 equals 15, carry 1. 3x3 equals 9 mas, plus 1 equals 10. We add them up. I get 5, I get 12, I get 2, and I get 1. So, 35 squared is coming out to 1,225, right? All right, let's continue. Now let's do 45 squared. So again, I'll have to do 45 times 45. 5 times 5 is 25, carry 2. 5 times 4 is 20. Plus 2 is 22. 4 times 5 is 20. Carry the 2. 4 times 4 is 16. Plus the 2 I carried is 18. We add it up. I get 5, 2, 10, and 2 totaling 2025, which is 45 squared. All right, so now what I'm going to do is move both the 1,600 and the 1,225 over here. Or, well, I think it's actually easier to do it the other way around. Let's see. Look, I'm going to leave this 1,600 here, and I'll also leave this 1,225 here, and this 2025. Let me do it better by subtracting 2025. On the right side, I'll write minus 80x as 80x. Let's keep it that way for now and continue working here. Let's see if we can do this subtraction in our heads, right? Yeah, it's easy, because here we have 1,225 minus 2,025. Well, the 25 and the 25 make 0. And here we only have this left. So, 1,200 minus 2,000, that would be minus 800. Right? And minus 800 plus 1,600. Well, that leaves me with 800. Right. On the left, I have 800 left. And on the right, we still have 80x. Let me move up a bit and continue the operation. We'll move the 80 to the other side by dividing. So x equals 80 divided by 80. That gives us x, and we cancel out here. That's equal to 80 divided by 8, which is equal to 10. Therefore, the solution would be 10 meters. Let me go back a little bit, just so you can see the drawing. Well, you can still see it there. So, the solution is that the distances must be equal. Specifically, the distance marked here, though it's hard to see. But anyway, those distances from here to here should be 10 meters. That's the solution, okay? I mean, obviously, from here to here, there have to be 30 meters, right? But anyway, it's asking me from the tallest building, okay? It says, at what distance from the tallest building? Okay, should it be located? Blah, blah, blah. So, the correct answer was 10, therefore. Let's circle option E. Let me see. So let's check if we got it right. It's exercise number 25, and it says the answer has to be E. So yes, it's correct. All right. Perfect. Let's continue. Let's move on now to the next exercise, which is number 26. In the following rectangular array, what is the missing number? Okay, look, in this case, I want you to see that here we are given some numbers, and honestly, it's pretty easy to figure it out. Why is that? Because look, if you do 3 times 2, 3 times 2, I'll write it here. You get 6, right? Well, let me change the color so it's clear. I'll put it up here. 3 times 2 gives me 6, and then 6 times 2 gives me 12. I did 3 times 2 got 6. 6 times 2 1 2. Let me check. Here, 7 times 2 does give me 14. And 14 times 2 does give me 28. So just multiply by 2. 5 times 2. Yes, that gives me 10. And now I would have 10 times 2, which is equal to 20, right? Therefore, the number that should be there would be 20 super easy, right? Exercise number 26. It says the answer has to be C. Correct? Simple. Let's continue to the next exercise, which is similar. It asks, in this rectangular arrangement, which letter is missing? It's a lot like the last one, right? In this case, we can't do operations, so we need to check what's happening in each row. Here I recommend that we write out the entire alphabet just like that. I mean, I'm going to write A, B, C, D, E, F, G, H, and so on. E and J, K, L, M. Well, up to M, right? Because that's where it goes. Let me check if I'm correct, okay? A, B, C, D, E, F, G, H, I, J, K, L, M. I'll stop here and start with this one. We have the A. We have the E. Yes. And we have the I. Let's see what we notice here. As you can see, he's leaving 3 letters out here, and he's also leaving 3 letters out over here. So, what does it mean that the E is exactly halfway between the A and the I? That's why they put it here. Let's see what happens with the last line. If this happens again, we know how to solve it, right? Here we have the E, then we have the I, and we have the M. As you can see, it's the same here, right? They skipped 3 letters, and here they also skipped 3 letters. Why? Well, because the I is exactly in the middle between the E and the M. It's simple, right? So, what should the correct answer be? The one that's between the C and the K. We find the C and we find the K. So we're going to move 3 spaces here as well. 3 spaces. And who is left here in the middle? Well, it's exactly the G. So the correct answer should be G. So we circle option B. Let's see if this is correct. Exercise 27. It says that the correct answer is B. So yes, we got it right. Easy, right? All right, let's move on to the next exercise, number 28. It says, to prepare some desserts, Sarah will need sugar. For the cake, she'll need 3/8 of a cup. And for the cookies, she'll use 3/4 of a cup. If there is only 15/16 of a cup of sugar, which of the following options is correct? Let's see first. So, let's calculate, or, well, yes, let's calculate the amount of sugar she needs. Okay, that would be 3/8 plus 3/4. So I'll write it here. She needs, and we add 3/8 plus 3/4. To make this addition easier, I'm going to convert these 3/4 to eighths, simply by multiplying the numerator by 2 and also the denominator by 2, right? So that I have eighths, so I would find an equivalent fraction. So this 3/8, let me write it. And here I'm going to add this new fraction. 3 times 2 is 6, and 4 times 2 is 8. So now we have this sum. Don't forget, this is what you need. Okay. Well, here we have a sum of like fractions, so I can keep the denominator and simply add the numerators. 3 plus 6 is 9. Let's see. You need a total of 9/8, but you only have... How much do you have? 15/16, okay? So the first thing we're going to do is compare. Let's see which one is greater, if what you need is greater, or if what you already have is greater. Let's see. We just need to compare 9/8 with 15/16. But since one is in 16ths and the other in eighths, let's make it easier. I can find a fraction that's equivalent to 9/8, but with 16ths to make the comparison easier, right? So let's do that. We multiply both the numerator and denominator by 2. 9 times 2 is 18. 8 times 2 is 16. Now it requires 18/16. And as you can see, well, 18/16. It's more than what he has, right? He has 15/16. It's more, right? This is more, so he needs more than what he has. Therefore, with this we can already get an idea and solve the exercise. Let's see what it says. Section A. He doesn't have enough sugar. He actually needs more, right? Does he need 9 more quarters of a cup? I'm not sure. Maybe he does. Let's continue. He needs 3/16 of a cup. We aren't sure of the exact amount, but we'll calculate it now. He has 3 left over. No, actually, he doesn't have any left over, right? Because she has less than what she needs, right? Remember, she needs 18/16, but only has 15. So actually, she doesn't have any left over. So the answer is between B and C. How can we figure out how much she needs? Well, just a subtraction, right? What are we going to do? Well, we're going to subtract from 18/16, which is what she needs, what she has, which is 15/16. And this subtraction is super easy, right? In this case, we'll keep the denominator and just work with the numerators. 18, minus 15 is equal to 3. So what's missing is 3/16. So the correct answer will be option C. That's it, we're done. So exercise number 28 is C. Let's see what it says here. It's C, so we got it right. Well, I had already put it there. Perfect. Let's continue with exercise 29, where they give me several fractions. The one with the highest value is, let's see. In this case, notice that we can quickly eliminate. They're not going to be. Answer. All those that are proper fractions, remember that proper fractions are the ones where the numerator is smaller than the denominator. And why do I say that we can already eliminate them right away? Because, let's see. the graphical representation of a proper fraction is something like this. Look, for example, here 1/4. 1/4? Well, that's it, right? It's 1 out of 4 in total. But look, for example, at a fraction that is improper. In this case, we have 5/3, so it would have to be 1 whole and then 2 more thirds, right? If we set it up this way, we'd have 1/3, 2/3, 3/3, 4/3, and 5/3. That's how 5/3 would be shown graphically. So, all those that are proper fractions, it's because they don't even reach 1 whole. So, necessarily the answer, since we have proper and improper fractions, would have to be an improper one, meaning one that's greater than 1 whole, right? First, I'll eliminate the proper fractions. So, not this one, not this one, but this one, and this one could be. Let's see. There are 2 different ways we can go about figuring out which of the 2 fractions is greater. The main one, which is the one I'm going to use, is by directly comparing the fractions. And the second would be converting them to decimals. And the one that has the larger decimal will be the answer, right? Can you do it that way too? I'll do it directly with the fractions. Watch how I do it. Look, I'm going to write 5/3, and let's see if it's greater or less than, for example, 9/8. So come on, let's do this comparison. What you do is simple. Just cross multiply. So 8 multiplies by 5. 8 times 5 is 40, and you put it up here, then you also cross multiply. 3 times 9 is 27. 3 times 9, 27. And wherever the bigger number is, whether it's on the left or on the right, wherever the bigger number is, that means that's where the bigger fraction is. In this case then, the bigger fraction will be 5/3, right? Since here we have a 40 and here a 27. Therefore, 5/3 is bigger than 9/8. Okay, so now does this 5/3 move on to the next round? Who will it compete against? Not these, since those aren't the answer. It'll compete against 8/5, right? So let's put it in place and do the cross multiplications. 5 times 5 is 25, and 3 times 8 is 24. So again, 25 is bigger in this case than 24. Therefore, 5 divided by 3 is greater, right? And that's the solution. Oh, sorry. So 5 divided by 3 is greater. And where is that? Oh, it's right here. So the correct answer will be option A, exercise number 29. Yes, it's A. So let's go to the guide. Remember that what I did was print out the answers, so I could check them directly here with you. All right, let's move on to exercise 30. We have 30, 31, and 32 left. We're almost done. Come on, let's go with number 30. See that in this case, we have a slightly complex operation with fractions. In this case, I recommend that we do it little by little. First this operation, then the next, and finally we'll divide. That way you won't get confused. So let's see. I'm going to copy the 3, 2, minus the 2, 3, and then we'll do the operation. I mean, from what's here. Here, I'll use the butterfly method. Multiply diagonally twice, then multiply downward. Okay, let's do it. 3 times 3 is 9 minus. Oh, 2 times 2. Sorry, is 4. This is divided by 2 times 3, which equals 6. 9 minus 4 is equal to 5, and here we have 6. So in the numerator, where do I put it? I'll put it here, okay? Well, here in the numerator, I end up with 5/6, okay? And now let's go with the denominator. Here we have 3/2 plus 1/4. In this case, it's easier if we do it with the least common multiple. The least common multiple of the denominators is 4, right? So we put the 4, and I do 4 divided by 2 equals 2 times 3, which is 6, plus 4 divided by 4 is 1 times 1, still 1. 6 plus 1 is equal to 7, 7. What fourths? So, the result of this sum of fractions is 7/4. Careful here, because some of you might say, hey, isn't the teacher showing how to add fractions? No, I'm not teaching how to add fractions, and that's not my intention right now. Why is that, right? We're solving exercises here, so you can practice and understand how they're solved. But if you say, oh, I didn't really understand how to add or how to subtract, in this case with the butterfly method, then look it up in the video. Or, if you didn't understand how the addition was done with the least common multiple method, look it up. In fact, there's a video here to make it much easier. In the video description, I'm going to put the links for each of the topics you need to solve the exercises. If I know you need to add fractions, I'll share the adding fractions video for you. If I know equations are needed, I'll add a video on them and do this for all exercises. So if you have questions about any of the topics that were needed, you can go directly to the links I'm going to put down below. All right, let's continue. Look, when we have a fraction over another fraction, we can also do two things. We can arrange them like this. So, like 5/6 divided by 7/4, we can do this and then just multiply 5 times. 4, 20 over 6 times 7, 42. We simplify to 10 over 21, and we're done, right? So the answer would be option C, right? So could we do that, or could we also do the following? We use a rule called the rule of extremes and means, which tells me to multiply the top number by the bottom number. 5 times 4 is 20. This goes in the numerator, and then I multiply the two middle numbers. That's why it's called the rule of extremes and means. 7 times 6 is 42, and I want you to see, 42. I want you to see that I'm getting the same result. Already simplified. Sorry, I'll move it here to avoid crowding. Already simplified. So it's 10/21. See, it's the same as what I have here, right? If you remember the rule of extremes and means, just apply it directly. Otherwise, rewrite it. Dividing fractions uses cross multiplication. 5 times 4 is 20. 6 times 7 is 42. All right. Well then, the answer to part C has to be, the answer to exercise 30 has to be part C. And yes, we have it. Good, let's continue. Let's move on to exercise number 31. A car can travel 180 kilometers with 12 liters of gasoline. How far can it go with 20 liters? This is a rule of 3 problem, right? So, let's go ahead and put the kilometers over here and the liters over here. So we already know that it goes 80 kilometers with 12 liters of gasoline. Then it says, what distance, so this is x, can it travel with 20 liters? All right, here's what I usually do. I multiply these two across, that is, the two that are across from each other, not with the x. And I'm going to divide it by the one that's across from the x. Look, so I get that x equals, I multiply these two. That would be 180 times 20, and I'm going to divide this, 180 times 20. And I'm going to divide this by the one that's across from the x, which is 12. That's it. We just need to do this operation. Here's a quick technique for it. Let me break it down. And 180, instead of leaving it as 180, let me write it as 60 times 3. 60 times 3 is still 180, right? And 20, I'll write it as 5 times 4. 5 times 4 is 20, so I'm not doing anything unusual, right? I'm just expressing them as a product of two factors. 60 times 3 is 180, and 5 times 4 is 20. I do something similar with the denominator. 12 can be written as 3 times 4. And let's see. The reason I'm doing this is because I already know that 3 divided by 3 is 1, so I can cancel them out. I put it in quotes. I'm not really canceling. Since the division equals 1, like 4 divided by 4, I can cancel them out. Therefore, I get x equals 60 times 5. It's simple. 6 times 5 is 30. Then I add the 0 I left out. The answer then is 300 liters. Where is that? 300 kilometers, not liters. 300 kilometers, since it was here, right? So the answer is 300 kilometers, right? Option D. Let's check if that's correct. Question 31. It has to be D. So there we go. We got it right. Okay, let's go with the last question. It says exercise 32. 0.56% of the number n is 196. What is the value of n? Okay, so it would be 0.56% is 196, right? And so we want to know what 100% of that number is. Right, so this is what we don't know. Again, it's a rule of 3. Look, if 0.56% of something is 196, then 100% of that something, so the number by itself will be x. So let's do the rule of 3 again. Remember that what I do is multiply the two numbers that are not crossed with x, and then we divide by the one that's crossed with x. So in this case, we have 96 times 100, and this is divided by 0.56. Like this, right? Well, the division is going to be a little complicated, but let's do it my way. In this case, I'm going to do the multiplication on top. So, 196 times 100 would be the same as just writing 196. Add 2 zeros, and below is 0. 0.50, 0, 56 to remove the decimals. Thoughts? So let's move 2 spaces here, but if I move 2 spaces, I have to add 2 zeros to the numerator, right? So I end up with 196,000, and I add 2 zeros, 1, 2. Remember, I'm adding 2 zeros because here I'm moving 2 spaces, so it becomes 106,000. What should we do with 196? 1,960 divided by 56. That's the operation we have to do. So let's do it. But look, I'm going to give you a little tip here. This tip is very, very basic. Look, we have it like this, and then 1, 2, 3. There it is, right? 1,960,000. It's going to be divided by 56. Let's see. The tip is the following. Start by dividing normally, but if the first digit already reveals the answer, stop immediately. What do I mean by that? First, I ask how many times 56 fits into 196. It's about 3 times. Let me multiply to check. 3 times 6 is 18 carry 1. 3 times 5 is 15, plus the carried 1 is 16, then I subtract. Here it becomes 16 minus 8 is 8. It turned into 8 minus 6 is 2. And well, here it's 0. So I get 28 place a 0 here, which is this one, and I'll stop since I have the answer. Careful, I haven't finished doing the division, but I don't even need to finish it. Why is that? No, because I already know that the answer starts with 3, and the only one that has a 3 like that is B. And that's it. So the answer is 35,000. I'll finish the division now. Actually, it's not even necessary. You'll finish it since we already know the outcome. I know the next one is a 5C. I already know that. 5 times 6 is 30. I carry 1. Sorry, I carry 3. 5 times 5 is 25. And the 3 I carried makes 28. See, it's working out, right? This will be 0. And well, here I can keep bringing down zeros. And here are the missing zeros. So it will work out, right? That's how it is. So that's it. The answer had to be 35,000. Why not any others? Because, as you can see, this one starts with 1, with 1 with 1, and with 4. And our answer had to start with 3, so the correct answer has to be option B. Let's see. 3, 2, 6, 7. All right, that's it. And well, with that, we're finishing up. So this is part 2 of 6 of our guide for the Metropolitan Autonomous University. If you liked this video, please share it with people you know who are studying for their exam and who you think could benefit from this material. It's always important to study so that we can get a good grade on the exam and be accepted into the university of our dreams. See you next time. Take care and behave yourselves. Bye-bye.